Hello everybody, I hope you're fine. In this video, I'm going to show you how PLSpredict analysis is performed in a smart PLS. So this is the procedure for carrying out PLSpredict analysis, and what you need to know is that when you run PLSpredict analysis, you have to focus on the key target construct in your PLS model that is normally measured reflectively. So after running this type of analysis, what you need to know first is that you should focus on PLSpredict values for all of the items or indicators of your measurement model. And you have to make sure that all of these values are greater than 0, which indicates that the PLS past model's prediction error is smaller than the prediction error given by the most naive benchmark. So after meeting this requirement, you have to focus on the distribution of the prediction errors for the PLS based on PLS methodology. And if the distribution of the prediction errors is symmetric, you should consider RMSE prediction error values for your evaluation. And in case that the distribution of the prediction errors based on PLS is not symmetric, you have to focus on MAE values for your interpretation. So after checking this, you have to make a decision on selecting whether you would like to focus on your analysis based on RMSE or based on MAE. And now at the last stage, you have to compare the prediction errors based on PLS and also based on linear model. And what you want to see is that the prediction errors of the items based on PLS are smaller than the prediction errors of the items based on linear model. So there are a few points here. In case that for all of the indicators of your target construct, the prediction errors based on PLS are smaller than the prediction errors based on linear model, it means that you have high predictive power. And in case that for a majority or the same number of the indicators, the prediction errors based on PLS are smaller than the prediction errors based on LM, it means that you have medium predictive power. And in case that for a minority of the items, the prediction errors based on PLS are smaller than the prediction errors based on LM, it means that you have low predictive power. And in case that for none of the indicators of the target construct in your PLS model, the PLS prediction errors are smaller than the prediction errors based on LM, it means that basically predictive relevance is not confirmed in your model. So this is the entire procedure, and it's quite straightforward to run PLSpredict analysis in a smart PLS. So let's just go to the software and run this analysis. Okay, so this is my PLS model. As you can remember, I have two predictors. One of them is communication skills, the other one is creating value, and I also have work motivation and job satisfaction. Job satisfaction is a mediator in my model, and the key target construct is work motivation. Also note that age serves as a control variable in my model. Okay, so to run the analysis, let me just click on calculate button, and then from this list I select PLSpredict. I don't need to change any of these values, the default values, so I just click on start calculation. It just takes a very short while. Okay, so this is the results report for PLSpredict analysis, and as you can see, I have the Q-square predict values for all of the items of job satisfaction and work motivation. I also have RMSE and MAE values for, again, the items of job satisfaction and work motivation. But remember, I told you that we just need to focus on the items of work motivation because work motivation is the key target construct in my model. We have the same statistics for the LM, and again, you can see the Q-square predict values. Of course, we don't care about them. We don't focus on them. And we have RMSE and MAE values for the items, and you can see these values. So the first step is to check whether the Q-square predict values for the items of work motivation are positive. And as you can see, all of these values here that I'm showing you, these values are all positive, which means that we have met the first requirement Remember, the first requirement was that the QSpredict values for the items of the key target construct in your PLS model should be positive values. Okay, so the next step is to focus on the distribution of the prediction errors of the items of work motivation as the key target construct in our model based on PLS. And to check the distribution of the prediction errors, I can simply click on PLSmv error histogram, and you would see that I have a histogram for any of the items of job satisfaction and work motivation. Again, I remind you that we have to focus on the items of work motivation, so I just click on this item. You would see that it's somehow skewed, this one a bit skewed. And if you click on any of these items, you can see that the prediction errors seem to be skewed. So I have to make a decision whether I would like to consider MAE prediction errors or the RMSE prediction errors. And here, based on my visual inspection, I think that there is no symmetry here, and I have to focus on MAE prediction errors. Alright, now that I have made a decision about focusing on MAE values or MAE prediction errors in my analysis, I just need to compare the MAE values for the items of work motivation based on PLS and also based on LM. So what I need to do, I can simply click on PLS tab, and then I click on Excel format. Then I open my Excel file, Excel program, and now I just paste the information here. Again, I go to my Smart PLS. This time I click on LM, I click on Excel format, and again I paste the information here. So let me just delete some information and the statistics that I really don't need to keep here. Basically, I'm not interested in the items of job satisfaction, so I just delete these rows. Also, the QSpredict value are not required based on LM, so I just delete them. And another point here is that MAP values, these are another type of prediction errors, but normally we focus on RMSE and MAE for both LM results and also PLS results. So let me just delete this column and this column. So another point here is that since we made a decision on focusing on MAE values, again I just delete RMSE column for the LM results and also RMSE column for the PLS results. And these are the remaining statistics that we need to focus. So to make a comparisons between the MAE prediction errors based on PLS and also based on LM, I can simply deduct the statistics under LM from the statistics under PLS. So let me just key in the formula for this. So the MAE prediction error for this item WM7 based on PLS minus the MAE prediction error for the same item but based on LM. And now you would see that it is a positive value here. Let me just copy the formula here. And here you would see that for one item, let me just change the color, for this item, for this item, and for this item, for 3 items out of 1, 2, 3, 4, 5, 6, 7, 8. So for 3 items out of 8 items, the prediction error based on PLS results is smaller than the prediction errors based on LM results. And if you check the information here, you would see that basically, since for minority of the items, the prediction errors based on PLS methodology are smaller than the prediction errors based on LM, I have to conclude that my model has a low predictive power. I have also created a table and summarized this information in that table so that in case you would like to report the results of PLSpredict analysis, you can use this table. So let me just open this file. All right, and here you would see that all of the items for work motivation, I have the MAE prediction errors based on PLS, and also I have the MAE prediction errors for all of the items based on linear model. And here you would see that I have the MAE prediction errors based on PLS minus MAE prediction errors based on LM, and you would see the results here, and we only have the negative values for all of those three items. So this is how you can simply create a nice table to report the results of PLSpredict analysis. And the interpretation also is here, since for the minority of the items of work motivation, the MAE prediction errors are smaller than the MAE prediction errors based on the linear model, the out-of-sample predictive power of the model is low. And here again you would see the guidelines in terms of interpretation of these results. All right, thank you very much, and I hope you like this video.